Today we're going to learn a little bit about matrices. So let's start by defining what a matrix is. A matrix is a rectangular array of numbers enclosed in brackets. Here's an example here. I've got these square brackets, and inside I've got the numbers 1, 2, 3, 4, 5, and 6. So I read this matrix as m by n, where m is the number of rows. A row is the horizontal line of entries. So for example, 1, 2 going across, this is a row. This is row 1. And then 3, 4, this would be row 2. And then 5, 6, this would be row 3. Okay, well, a column then is the vertical line of entry. So for example, down this column, 1, 3, 5, this is column 1. And 2, 4, 6, this would be column 2. So columns go down, rows go across. And in this example, the 3 by 2 above, there are 6 entries. Entries are the things that are inside here, contained within these 3 rows and 2 columns. So what we're going to do is we're going to be using these matrices and doing some kind of basic operations to start off. Today we'll just talk about adding and subtracting matrices. Well, let's talk about adding matrices. In order to add matrices, they have to have the exact same dimensions. So when I look at this here, this is a 3 by 2. There's 3 rows by 2 columns, and this is another 3 by 2. There are 3 rows by 2 columns. And if they are exactly the same dimensions, then you're just going to add the corresponding entries. In other words, what we're going to do here is this top left number, if you will, and this top left number, we're just going to add those together, 1 plus 6. Okay, and then 5 plus 2 is going to go top right to top right. Middle left to this middle left, 4 plus 3. Middle right to this middle right, negative 4 plus 5. Bottom left and this bottom left, 7 plus negative 8. And finally, bottom right, 2 plus 6. Now actually do this addition. This is 1 plus 6 is 7. 5 plus 2 is 7. 4 plus 3 is 7. Negative 4 plus 5, okay, not 7. This is a 1. 7 plus negative 8 is negative 1. And 2 plus 6 is 8. Okay, this matrix is what these two added together would be. 7, 7, 7, 1, negative 1, and 8. I can do this for subtracting matrices as well. In order to subtract matrices, they also have to have the exact same dimensions. So again, this 3 by 2, this 3 by 2, since they're exactly the same size, I can subtract these corresponding entries. And we do that the exact same way. So this top left minus this top left, and so forth. So this will be 1 minus 6. 5 minus 2 is going to go in the top right. We'll have 4 minus 3, middle left. Negative 4 minus 5 for the middle right. 7 minus negative 8, bottom left. And 2 minus 6 in the bottom right. All right, now actually subtract. 1 minus 6, this will make negative 5 in the top left. 5 minus 2 is going to be 3 in the top right. 4 minus 3 is going to be 1 in the middle left. Negative 4 minus 5 is negative 9 in the middle right. 7 minus negative 8, so that's going to be 15 in the bottom left. Careful with your negatives. And then 2 minus 6 is going to be negative 4 in the bottom right. All right, so this matrix here is what these two, this one minus this one, ends up being. So you're going to come across some different problems where I'm just going to name a bunch of matrices, and then I'm going to have you say, okay, what is maybe A plus B, or maybe what is A plus C, or maybe what is D minus B. Okay, so that's going to look like this. Add or subtract if possible. Let's take a look at the different matrices that I've got. W is this matrix 3, negative 2, 1, 0. X is this matrix going across row 1, 4, 7, 2, and then row 2 is 5, 1, negative 1. Y is 1, 4, and then negative 2, 3. And Z is 2, negative 2, 3, and then row 2 would be 1, 0, 4. What I would do is I would write down the dimensions for each of these matrices first, just to make it a little bit easier as we're taking a look at these different examples. So W is a 2 by 2 matrix because it has 2 rows by 2 columns. X is a 2 by 3 because it's got 2 rows by 3 columns. Y is a 2 by 2, 2 rows, 2 columns. And Z is a 2 by 3, 2 rows, 3 columns. All right, number 1, W plus Y. So I've got this W plus this Y. The first thing I check, are they the exact same dimensions? W is a 2 by 2, Y is a 2 by 2. Good. That means I can add these together. So let's write down what W plus Y would look like. W is the matrix 3, negative 2, 1, 0. And I'm going to add that to Y, which is 1, 4, negative 2, 3. All right, when I add these together, I'm going to add the corresponding entries. So I've got 3 plus 1, negative 2 plus 4, 1 plus negative 2, and 0 plus 3. All right, what's my answer going to be then? 3 plus 1 is 4 in the top left. Negative 2 plus 4 is going to be positive 2 in the top right. 1 plus negative 2 is going to be negative 1 in the bottom left. And 0 plus 3 is 3 in the bottom right. So W plus Y is going to be this matrix, a 2 by 2, 4, 2, negative 1, 3. Okay, what about number 2, X plus Y? When I look at X, it's this matrix right here. It's a 2 by 3. And Y is this matrix right here. This is a 2 by 2. Note, they do not have the same dimensions. Since they don't have the same dimensions, I cannot add these together. So I'm going to put no solution. And cannot add these matrices. As they have different dimensions. Okay, and these are the same matrices here. I'll just write their dimensions again. See, this is a 2 by 3. Y is a 2 by 2. And Z is a 2 by 3. All right, then number 3 is asking, what about X minus Z? X minus Z. X is a 2 by 3. Z is a 2 by 3. They're the same dimensions. Okay, so I can subtract these together. Let's see what that looks like. Let's write X over here first. So that's 4, 7, 2, 5, 1, negative 1. And I'm subtracting. C is 2, negative 2, 3. And then 1, 0, 4 for the bottom row. Okay, so let's subtract the corresponding entries. That'll be 4 minus 2 in the top left, 7 minus negative 2 in the top middle, and then 2 minus 3 in the top right. For the bottom row, we got 5 minus 1 in the top bottom left, 1 minus 0 in the bottom middle, and negative 1 minus 4 in the bottom right. All right, final answer. I'm going to have the matrix 4 minus 2 is 2. 7 minus negative 2, that's going to make 9. 2 minus 3 is negative 1. And then for the bottom row, 5 minus 1 is 4. 1 minus 0 is 1. And negative 1 minus 4 is negative 5. All right, that'll do for our entry into matrices, as well as some basic operations, adding and subtracting. Remember, when you go to add or subtract matrices, they have to be the exact same dimensions. And if they are the same dimensions, then you go ahead and add or subtract their corresponding entries. If they're not the same dimensions, then you don't have a solution there because you couldn't add or subtract them to begin with.